In the previous class, we discussed the method and the principles of the extraction of the ore. So under that, we discussed how the ore is concentrated, then how the conversion of ore into desired compounds and oxides. The third method or the principle of extraction of ore is the reduction of ore to form a crude metal. The third method under the principle of the extraction of ore is reduction of ore to form a crude metal. So yesterday we discussed a very important concept, that is elegant diagram. So this elegant diagram mainly explained which is a best reducing agent. Means the conversion of metal oxides, means the reduction of metal oxides to reduced into the formation of what? Metal. So we are using the diagram, elegant diagram. It explained briefly how the metal oxides get reduced into a metal by adding a suitable reducing agent. By adding a suitable reducing agent, we can reduced a metal oxide into a metal. Metal oxide into metal using a suitable reducing agent. In the elegant diagram, we discussed which is a best reducing agent. Then what about the standard free energy change, whether it is in positive or a negative, or it is means whether it is in spontaneous, whether it is non-spontaneous, or it is in equilibrium. Yes. So now today we will discuss how the metals are extracted. So here it consists of what the metal oxides, how it will be reduced into its metal through extraction. Through extraction, how this metal oxide will get reduced into the metal. So we will go through a variety of extractions of metal. A variety of metal they will undergo extraction to get a crude metal. To get the crude metal. Yes. So now the first extraction is the extraction of iron. Extraction of iron. So the extraction of iron, it is how to extract the iron. So in the first class, I already told that how which is the ore of iron, which is the ore of zinc, like that we discussed in one chart, right? So we can extract the iron from where? From it is having from ore. From ore we will extract the iron, right? Yes, we will get the iron from its ore. So which ore we are used in the extraction of iron? Which ore is used in the extraction of iron? So that the ore is hematite. So hematite is the ore is mainly used to extract the iron from the ore we call hematite. Yes. Here we get, so in the first class I told that all the ores are mineral, but all the minerals are not ore. We know that the iron having so many ores. That is what, for example, that is hematite, magnetite, siderite, iron pyrites, leminoid. So all of those are what? They are the ores. But under that, we use the hematite for the extraction of iron. For the extraction iron, we use the ore called hematite. Yes. So this process, this extraction, mainly explained with one instrument. We call it with one instrument. That is, we are using in this extraction of iron, that is blast furnace. Using which the operators we are using. Here it is blast furnace. Through that we come to understand so how the process will take place, how we extract the iron from this ore. From the ore. So in this extraction of iron, as this extraction of iron takes place, so many steps are there. So many steps are there how to extract the iron. So what are all these the steps? First we have to do the process. First we have to do the process. The second one we have to do the smelting. The third one is the zone of combustion. The fourth one is the zone of reduction. The fifth one is the zone of slag formation. And lastly, the sixth one is a zone of fusion. So these are all the steps are there. Means by extracting this iron, extraction of iron from this ore, we have to follow the steps. Got it? So first we will draw this blast furnace, then we come to understand very easily this concept. So this is a blast furnace. So this is how it's get arranged. So now, first, that as I told now, that the first thing is we have to do the process. The first step is what? The process. So the process, in the process what we have to do? So here we are going to extract the iron, means you have to use the one ore to get that iron. So hence I am using here, we are using the ore hematite. So first we have to take the ore, then this ore is crushed. Then the ore is crushed and it's finally powder. Crush nam ಏನು ore ಸಿಕ್ಕಿದೆ ಅದನ್ನ crush ಮಾಡಿ finally powder ಆಗಿದೆ. The hematite ore is crushed and is finally powdered, and then it get concentrated. Now we have to concentrate this hematite ore. How to concentrate this hematite ore? First the ore is crushed, finally powdered, and then we have to concentrate this ore through hydraulic washing. Through hydraulic washing, we will concentrate the ore. We already know that it is the one of the type under the ore concentration, that is hydraulic washing. Here I am concentrating the ore, that is one of the type, that is hydraulic washing. So through this hydraulic washing, we get the ore, it will get concentrated, means it is washed away. The impure materials, the particles get washed along with the water, and the ore is get concentrated. The hematite ore is concentrated. Now this ore is get concentrated. Next we have to crush, finally powder. Then we have to concentrate the ore by hydraulic washing. We will concentrate the ore through hydraulic washing. Next, we have to heat this ore. We have to heat this ore with unlimited supply of air. So that we call as what? Where the ore is heated with high temperature below its melting point, with absence of air or with a limited supply of air. That process we call calcination. That process we call calcination. First we have to crush the ore, it will become finally powder. Thus finally powdered ore is washed with water. It is one of the type under the concentration of the ore, that is hydraulic washing. After this hydraulic washing, hence I am heating this ore through the process called calcination. So after this calcination, what happens? So what are all the moisture is present, that will get escape. The volatile oxides, then the impurities or get escape. In that, if it is any ferric oxide is present in this ore, they will get oxidizes to the formation of ferrous oxide. The ferric oxide get oxidizes. If it is any ferrous oxide is present inside this ore, it will get oxidizes to the formation of ferric oxide. The formation of what? Ferric oxide. The formation of what? Ferric oxide. See the process. So in this process, the hematite ore is crushed, it's finally powdered, and the ore is concentrated through the hydraulic washing. Then this heated, the process called calcination. So in the calcination, we have heat the ore, where the moisture escape and other organic matters and the impurities or get escape. If it is any here some of the this one oxide, what are all the volatile materials are there, they will get oxidized. Volatile metals are there, so they will get oxidizes to the formation of their volatile compound. So here what happens, if it is any presence of ferrous oxide is present in the ore, it will get oxidizes to the formation of ferric oxide. To the formation of what? Ferric oxide. So this is the first step, that is process. Then come to the next one, that is smelting. The second one is smelting. So what is this? Here in this smelting, the mixtures here, the ore means the hematite ore, the hematite ore, the limestone and the coke. So this three, that is what, the hematite ore, the limestone and the coke, this we have to introduce into this blast furnace in the ratio of 8:1:4 ratio, like this, 8:1:4. So now I will introduce into this blast furnace in the ratio of 8:1:4. So that's hematite ore, the limestone and the coke. So hence I am now just introducing this mixtures inside the blast furnace. See, inside the blast furnace I am introducing this mixture, that is hematite ore, limestone and the coke in the ratio of 8:1:4. 8:1:4 I am going to introduce inside this blast furnace. So this is the blast furnace. The blast furnace is like a long tower. It is like a long cylindrical tower. It is a long cylindrical tower. It is made up of steel. It is made up of steel and it is covered with bricks, iron, fire bricks. It is inside. It is constructed with an iron bricks. So now here a cup and cone arrangement, a double cup and cone arrangement is there at the top of the furnace. Here a widest portion of the blast furnace we call washes. The widest portion, this portion, the widest portion of this blast furnace we call washes. Here the widest portion, there is a hot air is blast inside the furnace through this pipe. Inside the furnace, the hot air is blast through this pipe. So below, through a water-cooled pipes, here we call it as in water-cooled pipes called tireless. These water-cooled pipes are present below this washes. So that we call as what? Tireless. Because this is a tireless and the bottom of this furnace there is a two separate outlet is there. To remove the molten iron, what we get the iron from through this extraction, that the iron and the waste impurity that the slag get from the separate outlet. And at the top there is an outlet is there to remove the waste gases. The waste gases will remove at the top of this outlet. So this is the arrangement of what? The blast furnace. So now in this smelting, I am going to introduce this mixture inside this. Means the ore, the limestone and the ore is nothing but here the hematite ore, limestone and the coke in the ratio of 8:1:4. So then now the process will start. What happened? Here ends and passing the hot air. The blast of hot air is passed inside the furnace. So what happened inside the furnace? Here is the coke and the limestone and the ore is there. Here the coke combines with oxygen, formation of carbon dioxide. So that process we called the third step is zone of combustion. A zone of combustion at this Kelvin, at 2170 Kelvin. This process will take place at this temperature 2170 Kelvin. So the zone of combustion. So here what happened? And so I am introducing this ore, limestone and the coke. This coke, here I am passing a blast of hot air, through this pipe. Here what happened? This coke will combines with oxygen and so will decomposes to the formation of carbon dioxide. Decomposes the formation of what? This is a solid and this is a gas. Formation of what? Gas. So this the coke combines with oxygen, formation of carbon dioxide. So here this, what about its enthalpy? The enthalpy is minus 406 kilojoules. Means what? The minus means what? Here it is an exothermic reaction takes place. The loss of energy, exothermic process will take place, exothermic reaction. So this, when the coke combines with oxygen, formation of carbon dioxide, hence this carbon dioxide moves up. Hence this carbon dioxide moves up, it will combine more and more coke. This carbon dioxide, again it will combines with oxygen. Combines with, this carbon dioxide combines with more and more coke. Formation of what? Carbon monoxide. Formation of what? Carbon monoxide. So this is a gas. So here where the enthalpy is positive, means it is an endothermic reaction, the absorption of where the energy will get absorbed. So this two thing, it will happen at the temperature 2170 Kelvin, that we call the zone of combustion. In the zone of combustion, where the coke will combines with oxygen with hot air, formation of carbon dioxide. This carbon dioxide moves up, combines with more and more coke, formation of carbon monoxide. Formation of what? Carbon monoxide. This, if it is any ferrous oxide is present in this, combines with carbon monoxide, formation of Fe and CO. Formation of what? The iron and the CO. The ferrous oxide, the oxide is there, it combines with carbon monoxide, formation of Fe plus CO. So this too is very important. So in the zone of combustion, this too will happen. So the next come to the next zone we call a zone of reduction. A zone of reduction. This zone of reduction that takes place at the temperature, at the Kelvin, 1070 Kelvin. 1070 Kelvin. Here the next step is the zone of reduction. So in this zone of reduction, what happened? At this low temperature, at 500 to 800 degree Kelvin, at 500 to 800 degree Kelvin, now at low temperature, so what happened if any magnetic oxide and ferric oxide, need a magnetic oxide and ferric oxide, the magnetic oxide and ferric oxide, they will get reduced when they are react with carbon monoxide to form, they are reduced with carbon monoxide to form a molten iron, So please who can understand this concept, please where the zone of reduction, hence it will take place at 1070 Kelvin. So at low temperature in here at 500 to 800 degree Kelvin, if it is any magnetic oxide and ferric oxide is there, will get reduced. They will get reduced with CO to the formation of what? Molten iron. So what happened? So here the ore and the coke is there. The hematite ore, that is what? The magnetic oxide or the ferric oxide we call. The ferric oxide Fe2O3, hence they will get reduced with CO to the formation of what? Ferric oxide. For the formation of this ferric oxide get converted into Fe3O4 plus C. See here what happened. So this any magnetic oxide or ferric oxide is there, it will get, hence it will reduce us with carbon monoxide to the formation of molten iron. So this ferric oxide will reduce this carbon monoxide to formation of ferrous oxide. So Fe3O4. Fe3O4. Next. So this Fe3O4, again it will reduces with the carbon monoxide, formation of the molten iron. The formation of what? This molten iron. Yes, it's fully balanced. Yes, see, look at this equation. So the ferric oxide, any magnetic oxide or ferric oxide are present in this sphere, this ore. So they will get reduces with carbon monoxide, the formation of ferrous oxide. This ferrous oxide again will combines with reduced with carbon monoxide to the formation of molten iron. To the formation of what? Molten iron. This Fe2O3. This Fe2O3 is the formation of ferrous oxide plus Cu. It's fully balanced. Yes. So this is about how we get this molten iron. How we get this molten iron. So hence we already get this molten iron at this temperature, that 500 to 800 Kelvin. So any ferric or magnetic oxide is present in it, they will get reduced with carbon monoxide to the formation of ferrous oxide. Again it will combines with carbon monoxide, reduced with carbon monoxide, formation of a molten iron. We will get the molten iron here. So the next what happened, here this molten iron, where we get it from the zone of reduction, we will get from the zone of reduction this molten iron. This molten iron we will get here at the top. So in this iron, it is very spongy. It will move down and settle at the bottom of this furnace. Here this spongy iron, this molten iron, it will move down, this spongy iron moves down and settle at the bottom of this furnace. It will melt and it will settle at the bottom of the furnace. So this iron we call a pig iron. This iron we call what? Pig iron, where it contains 4.5% of carbon. Where it contains 4.5% of carbon. This pig iron, the spongy iron where we get here at the top of this furnace, it will moves down through the along the furnace. It will moves down and it melts and collect at the bottom of the furnace. That iron we call pig iron. Where it contains, the pig iron contains 4.5% of carbon, and also it contains other impurities like sulfur, like silica, like magnesium, like carbon. So these are all the impurities are present in it. These are all the impurities are also present. Got it? Yes. So this pig iron is mixed with iron scarps plus coke. So this pig iron is again we will mix this pig iron with iron scarp and coke. So that we call as what? Cast iron. That type of iron we call cast iron. So this cast iron is where it contains 3% of carbon. It contains 3% of carbon. This cast iron contains 3% of carbon and it is very hard and brittle. The cast iron is very hard and brittle. So this pig iron here where it is collected at the bottom of this, here the bottom and of the furnace, presence of this pig iron where it contains 4.5% of carbon and other impurities are present. This pig iron is mixed with iron scarp plus coke. A traces of iron pieces mixed with coke to the formation of that iron we call cast iron. Cast iron where it contains 3% of carbon. So it is very hard and brittle. So now the zone of reduction. So these are all the things that will happen in this step, that is zone of reduction. So come to the next step. That is the next step is a zone of slag formation. The fifth step is a zone of slag formation. The formation of slag. The zone of slag formation at the temperature at 1270 Kelvin. 1270 Kelvin. This is the fifth step, that is zone of slag formation. So we are here the ore. We can the ore here which ore we are used here, the hematite ore is already in the zone of reduction. They will react it to the formation is over. They will come to the coke in the first step. The zone of combustion is over. So the left behind the mixture, that is what? The limestone. So what is that? So what is the function of this limestone here? So this limestone, that is what? CaCO3. This limestone, it will decomposes. This limestone, it will decomposes to the formation of CaO plus CO2. CO is nothing but the quicklime. Quicklime, or we call it as a calcium oxide. We call it as a quicklime, or another name is calcium oxide, where the carbon dioxide gas, it will escape. It will come out through the waste gases, the CO2 gas. So here the limestone, the composition of the limestone is calcium carbonate, that is CaCO3. It will decomposes at this temperature at 1270 Kelvin. It will decomposes to the formation of a quicklime or a calcium oxide plus CO2 gas. It will release. So this calcium oxide combines with this quicklime, combines with the impurity, that is here there are the impurities, that is mixed with the impurities, that is silica dioxide. So formation of what? So calcium oxide plus silica dioxide. So here the formation of CaSiO3. CaSiO3. We call this is a slag. Next, this is called, we call it as a slag, and it is a flux, and this is a gangue. Means an impurity. So this is a major part. This calcium oxide, what is in flux. Here we have another name is quicklime. This combines with the gangue, means the impurity what we get in the zone of reduction. In the pig iron consists of the impurity, that is silica dioxide. So when the calcium oxide or the quicklime combines with the gangue, the formation of what? Calcium silicate is nothing but the slag. So this zone we call this zone of formation of what? Slag. Zone of slag formation. Here we get the slag. So where the slag is collected, where it is present. So here all this process takes place under this Kelvin, 1270 Kelvin, this temperature. So the formation of what? The slag will form. Hence this slag, hence they will comes down and they are collect at the bottom of this furnace above this molten iron. Hence the slag will collect above the molten iron, hence they form a separate layer. They will form a separate layer and they will deposit it or collect it at the bottom of the furnace above the molten iron. This slag they will get deposited above. The slag, it will collected above the molten iron and they form the separate layer. Why? Because the slag is lighter than the molten iron. Means the molten iron is heavy. So it is collected at the bottom of the furnace. Above the molten iron, a slag will form. The slag will collect above the molten iron. It is very lighter and they form a separate layer. So that we call as a slag. So and also this slag will prevent the oxidation of this iron. This slag will also prevent the further oxidation of the iron. It prevents oxidation of what? Iron. Hence they are deposited or settled at the bottom of the furnace above this molten iron, hence they prevent the oxidation of what? Iron. Hence they prevent oxidation of the iron. So the zone is the zone of slag formation. Let the the fifth one is a zone of how the slag will form under this temperature. This at 1270 Kelvin how it is formed. And lastly, come to the last step. The last zone or the last step is a zone of fusion. The last step we call a zone of fusion. The zone of fusion, it takes place at the temperature 1570 Kelvin. 1570 Kelvin. The last one is the zone of fusion. So in the zone of fusion, what happens? Here the impurities are there. Hence this molten iron will absorb that impurities in this temperature, in this Kelvin. So at this temperature, this molten iron, what we get this molten iron, it will absorb the impurities like silica, like carbon, like sulfur, magnesium, carbon. So these are all the impurities are there in the zone of fusion. So in the zone of fusion, the molten iron will absorb some impurities are there in this process. And lastly, we will separate this slag and the molten iron through a separate outlet. So here we can remove the cast iron. It is first we will remove the slag. It is very lighter part from the separate outlet. Here we can remove the slag and after removing the slag, the heavier part, which is molten iron, hence we remove from this. That is nothing but the cast iron. We can remove from this outlet. This is how we can extract the iron through the blast furnace. So this is one of the instrument we are using for the extraction of iron, that is blast furnace. A very important this one is very important. They will ask mainly for 3 or 4 marks for the extraction of iron. So this extraction of iron takes place in 4 steps. This 4 steps, including the 2, that is the process and the smelting. Totally the 6 steps are there. Very important. That is the first one. Once again, I am repeating this. The first is the process. The second one is the smelting. The third one is the zone of combustion. The fourth one is a zone of reduction. The fifth one is a zone of slag formation. Then the last one is zone of fusion. The zone of fusion. So these are the step by step. We can easily understand the concept very easily. So the first we have to do the process. First you have to take the hematite ore. You have to crush that. Finally powder ore is introduced. Powder ore have to concentrate it through the hydraulic washing. Then it should be heated. The process called the calcination. Under the calcination, the moisture will escape. Thus any ferric oxide is present, it will get converted into ferric oxide. Next we go to the smelting. Under the smelting, we are going to introduce the mixtures like hematite ore, like limestone and the coke in the ratio of 8:1:4 inside this furnace. So what happened? The first, that is zone of combustion. So here the coke will combine with, when the hot air is gassed inside the furnace, the coke will combine with oxygen formation of carbon dioxide. This carbon dioxide moves up. Combines with more and more coke to the formation of what? Carbon monoxide. So if it is any ferrous oxide combines with carbon monoxide, formation of Fe. Then come to the fourth one, that is zone of reduction. Takes place in 1070 Kelvin. So at the temperature of the 500 to 800 Kelvin, any magnetic oxide or any ferric oxide are present in this. So what happens? It will reduce with carbon monoxide to the formation of molten iron. So hence we get the molten iron. So this molten iron, that will formation here at the top, it will comes down, the spongy iron, it comes down and settle at the bottom of this furnace. That iron we call pig iron. That pig iron is contain 4.5% of carbon and other impurities like silica, sulfur, magnesium and carbon. These are all the impurities are present. So for this pig iron, we are going to add a little bit of iron scraps and the coke, hence it will become that we call a cast iron. That is where it contains 3% of carbon and it is very hard and brittle. So then come to the fifth one, that is zone of slag formation. How the slag will form in this step? So if you take the limestone, that is a calcium carbonate, CaCO3 will decomposes to the formation of the quicklime, that is nothing but a calcium oxide, where the carbon dioxide gas will escape, then moves out, comes out as a waste gases. So this calcium oxide, this flux will combines with impurity, that is silicon, that silicon dioxide, with the flux and ganglion impurity, the formation of the slag. Where the slag is very lighter than the molten iron, is settled at the bottom of the furnace as a separate layer, and they are very lighter, and also it will prevent the further oxidation of this molten iron. And lastly, the last one is the zone of fusion. In zone of fusion, what happens is this molten iron will absorb some of the impurities such as sulfur, magnesium, or the carbon, and hence these two all get separated with a separate outlet. We can easily remove from this blast furnace. First, we will remove the slag that is having with lighter, and we come. And lastly, we will remove the cast iron having a heavier weight. So this is about how we can extract the iron through blast furnace. This is one of the very important how we can extract iron through this blast furnace. It is the extraction, that is extraction of iron through hematite ore.